Hello students, welcome back to your online session for physics class for today. I hope you all are doing well. So please stay safe. Now today we are going to begin with chapter number 6 and the name of the chapter is Magnetism. And you can refer to your physics book on page number 58 and you can start reading or you can just open the book and go through the video. Now let us get started. Now in this chapter what we are going to study and learn is all about magnets. Okay, what are magnetic and non-magnetic substances and characteristics of a magnet, then properties of magnets and magnetic field, then Earth's magnetic field, then making of magnets, how magnets are made, then permanent and temporary magnets and electromagnets, then how to store and care magnets, and demagnetization by heating, hammering, and electricity. These are the topics that we are going to cover in this chapter. So let us get started. Now I hope you all can see these few magnets that are kept over here. Now, how many of you have actually used magnet or like have just played with magnets? Because there are many things that we can easily do with magnets, right? So, what is the property of magnet? In easy language, we can easily say that a magnet attracts things towards it, right? It has magnetic property. As you all can see, this is a magnet and this is also a magnet. Now when I am bringing one magnet near to another one, so it is attracting it, right? Why is it so? Let us see the concept. Because the magnets have two sides, like one side is having north pole and another side is having south pole, right? So due to these poles, they actually attract each other or they actually repel each other, right? Now I'm not having a proper like a cylindrical or like u-shaped magnet. Through these kind of magnets we can easily see how they repel each other, but using these magnets I am unable to show that property, like how they repel each other. We can easily see how they are attracting each other, but they are actually not repelling each other. Now another thing that we need to see or that we're going to see is these things, right? So few of them are magnetic substances and few of them are non-magnetic substances. Now, how can we come to know about it? Let us see this sharpener. We are having something like some plate, steel plate over here. Now, when I am keeping the sharpener from this side, it is getting stuck to it, right? But what if I'll keep, see, all the magnets have attracted each other, right? So this is the property of a magnet. I hope we all know about it, because sometime or the other we all have played or used magnets in this way, right? Now this side of the sharpener is of plastic. Now when I am keeping it from this end, it is not attracting. We cannot like attract the magnet and sharpener, right? Similarly, this pencil is made up of wood, but so it is not getting attracted towards this magnet. Same way, this pen is not getting attracted towards it because it is made up of plastic, right? Now we'll see this scissor, pair of scissor. Now see, magnet is attracted to, see, this one also and this one also. So this is the property of a magnet, that they get attracted towards few kinds of substances, right? Similarly, I hope you all must have used the refrigerators of your house, right? So when you open the refrigerator, we need to apply like little bit more force to open it. Like we cannot easily open the door of a fridge, right? And then when we close it, so it is not necessary for us to just close it very like easily, right? Or we need not to apply much force to open the to close the door of a fridge. Why? Because the doors of a refrigerator have magnets, so they automatically or ultimately they just close by themselves because both the magnets attract each other and they just close by themselves. Sometimes it happens that yeah, we just leave it open and the distance is more, so that's why they don't get closed by itself. Okay, but many a times we see that it gets closed by itself. Now this is about like properties or like how magnets work. Now we'll see each magnet has two sides. Okay, one side is called as North Pole and another side is called as South Pole. And this is the reason, like, see, if this side is having North Pole and if I'll keep one more magnet over here, so this side should have South Pole. Only then the both magnets will attract each other. If this side again I'll keep like North Pole, then these two magnets will not attract each other, they will repel each other. Repel means they will go back. Okay, they will not come close, they will move back. Okay, just okay, repel each other. Now we'll see different kinds of magnets. I don't have like all kinds of magnets with me, so I'm just showing the pictures. Cylindrical magnet. A magnet which is having the corners of cylindrical shape are called as cylindrical magnet. Then bar magnet. A simple bar is there like this. So this kind of magnet is called as bar magnet. Then U-shaped magnet. Okay, U-shaped magnet, and this kind of shape is called as horseshoe magnet. And yes, one more place where we can easily see the working of magnet is the compass. Okay, this needle or magnetic compass. Here we see that this line or like this needle used to be there and it works on the principle of magnetism. Okay, you can see south, then north, then east, then west. Okay, so like wherever we'll keep it, it will ultimately show the direction of the sides. Okay, now there used to be one kind of like this suspension where magnet rest. Now if just consider if I'll just move this magnet, just move it, then later on or maybe after 2 3 or 5 minutes we'll see that it is resting again in this direction. South will be at this side and north will be at this side. So it shows that when a magnet is resting in free suspension, in freely suspended position, it will always rest in north south direction. Okay, now we will come back, we will get back to our book and let us read about it. Now see, we'll get back to the introduction part that is there in our book. The phenomena of magnetism was known to the Greeks as early as around 800 BC. They discovered that certain stones, now called magnetite, attract pieces of iron. The Chinese called it lodestone, i.e., the leading stone. A popular legend ascribes the name magnetite to the shepherd Magnus, the nails of whose shoes and the tip of whose stick stuck fast to the rocks while he pastured his flocks of sheep and goats to the nearby mountains. It seems as if the stick was being attracted by the rocks. The rock was a natural magnet, or it is also called as lodestone, and it attracted the iron tip of the shepherd's stick It is also said that the term magnetite and hence magnet comes from the name of a place called Magnesia in ancient Greece where natural magnets were first found. So in this introduction what we have read about is this phenomena of magnetism was known by to the Greeks. Okay, first of all they discovered this phenomena that something is getting attracted to other thing. Okay, they discovered that certain stones or rocks I should say, they discovered that they are attracting the like steel or iron towards it, and then now it is called as magnetite. It attracts pieces of iron. I hope you know those nails or keel I should say, the which we use in our houses or somewhere else. So they are like made up of iron. Okay, so they got actually attracted. Okay, in those times the Chinese called it the lodestone. It means leading stone. A popular legend ascribes the name magnetite to the shepherd Magnes. Because why? Like he named it because the nails of whose shoes, there was a man or a shepherd named Magnus, and what happened that time was that his shoes, okay, in which nails were there, okay, the nails of whose shoes and the tip of whose stick he was holding, and he was wearing some shoes in which nails some iron was there, and as he was going to mountains, okay, to pasture his flock of sheep, and there his shoes and stick stuck fast to the rocks. We can say that his stick and his shoes were getting attracted towards a rock. Okay, and it seemed as if stick was being attracted by the rocks. Rocks were attracting his stick because his stick was having iron. Okay, then the rock was a natural magnet. So actually that rock was a natural magnet, and that is why it attracted the iron tip of the shepherd's stick. Now see students, like there are two kinds of magnets. Okay, this one is artificial magnet. Okay, because it is man-made, and there are kind of like natural magnets in the form of some rocks or some stones. So they are called as natural magnets. Now it is also said that the term magnetite and hence magnet comes from the name of a place called Magnesia. So afterwards like that name is termed as magnetite, and this magnesia comes from that same place where ancient Greece for first found natural magnets. Okay, they found the natural magnet for the first time in Magnesia. Okay, in that is in Greece, and from there we got this name. Now regardless of the shape and size of a magnet, has two poles called North Pole and South Pole. We have already seen this, which exhibit forces on each other in a manner analogous to electrical charges. Electrical charges, like it happens only because of electrical charges. South pole have some other and North pole have some other. That is, like poles repel each other and unlike poles attract each other. This is what I told you, that if this is a magnet, at this corner we have North Pole and at this corner we have South Pole, and one more magnet if I'll keep besides it, and that will be having North Pole, so it will repel each other, and if that side will be having South Pole, then both of them will attract each other. Now we can see the figure of or the picture of this part. A part is, it is a natural magnet, okay, and he is the that man, that shepherd whose name was Magnes, and he was stuck on the mountain side, and he went there to uh, pasture his flock of sheep. shapes. Okay, now you might have come across magnets in your daily life. When you open the door of a refrigerator, you have to apply some force. This is because the door is held in a position by the magnet which is inside the door of a refrigerator. Magnets are also used as magnetic catchers in cupboards. Yes, in cupboards also we used to have magnet, and they work as magnetic catchers so that we won't leave the doors open. Okay, this is the concept that is being used so that we won't leave the doors open by mistake. They are also used in the speakers of audio systems. Perhaps you might have come across magnetic chess, magnetic ludo, and magnetic therapy to cure pain. Figures given below shows a number of uses of magnets. Yes, especially the toys or the things that we get nowadays have more usage of magnets. Or in earlier times, we used to get magnets in our TVs, radios, right? And now in audio systems, speakers also. See, this kind of chess, they have like magnetic property. Okay, they just use magnets. And similarly, the toys that we can see over here, refrigerator. Okay, these clips, the place there where we just stuck them all together is having a magnet. Okay, then again, this toy, some kind of toy is there, so it is also having magnetic property. Okay, now shapes of magnets. Magnets come in a variety of different shapes and sizes. Some of these magnets include a bar magnet, a horseshoe magnet, and a magnetic compass. So we have already seen a bar magnet looks like this, horseshoe magnet looks like this, and this is a magnetic compass. Okay, now let us see. A bar magnet is in the form of a rectangular bar or has a circular cross section. So this is a rectangular bar. Okay, then a horseshoe magnet is in the form of a letter U. So here it is, we have already seen this one. Okay, a magnetic needle. It is a small piece of magnetized needle in the form of an arrow head. The arrowhead is the north pole of the compass and the tail acts as south pole. The north pole is usually colored red. This needle is pivoted at the center and enclosed by a plastic or glass pieces on the both sides. This needle is used to find the direction of Earth's magnetic field and to test the polarity of another magnetic pole. Magnets can be put to a variety of uses. Some of these uses are full of fun. Yes, we can easily use magnets to just play with it or just for fun. One of the activity, even I can show it to you. So let us see that activity. Now see student, this is my almirah. Okay, and I hope you all can see there are so many magnets which I have collected. And again, just for fun, I just bought it and I used to collect these. Now there are so many things I can just create with this magnet. Like see, I can as it's like my own almirah. So generally what I used to do, I used to create the letter of my own name, and I hope you all know what's my name. So see, I am creating a letter out of it, out of these many magnets. Okay, so just combining two set of each design of magnet, I am doing this. So like there are so many activities and things that we can do using these magnets, and I hope that many of you also must be using these kind of magnets or maybe another shapes of magnets. See, I have created the letter of my own name from it. Isn't it looking cool? And even then, like, I'm left with these, so many more things I can create. Okay, many more things, not only a letter but many other things, right? So these are few of the activities that we can easily do just for fun. Now let us get back to our chapter. So this is what we have learned today. Like there are the introduction of magnets and magnetism, how we got its name and from which place. Then the uses, like the things that where we use such magnets, and shapes of magnets we came to know about. Now in our next class we will begin with magnetic and non-magnetic substance. Okay. Meanwhile, what you have to do, please read this part which we have discussed today for your better understanding. Now in our next class we will begin with this topic. Okay. So that is all for today. Have a good day, students. Take care.